This is the third example for the rational function graphing, and we're looking at r of x is equal to x squared plus 4x minus 5 divided by x minus 6. So I'm going to first of all factor the numerator. So that gives me x plus 5 and x minus 1 divided by x minus 6. Okay, so there are no common factors, so that means that there are no wholes. So I could just put none for the whole. Vertical asymptote, I set my denominator equal to 0, so that will be at x is equal to 6. There are no horizontal asymptote, so this one is none. And the reason is that the numerator's power is greater than the denominator's. Okay, however, there is a oblique asymptote. So let me just define how you know you have an oblique asymptote. So an oblique asymptote occurs when the numerator's power is exactly 1 greater than the denominator's power. And it's important that it's exactly 1. So if you have an x squared on top, it has to be an x in the denominator. If there's an x cubed on top, then there has to be an x squared in the denominator. So our problem has a oblique asymptote. Sometimes they call it as a slant asymptote. So we have our numerator's power that is equal to 2 and denominator's power that is equal to 1. And the way that you find the slant asymptote is you use long division. Okay, so I'm going to go back to the original problem and not the factored, and then I'm going to do the long division. So you have the dividend up on top that goes in the box. So that's x squared plus 4x minus 5. And then the denominator is the divisor that goes outside, x minus 6. And then you go through and do your division. So up here it'll have to be x and then multiply through, so that gives me x squared minus 6x. And remember, you have to subtract here. So then this will become 10x, and then I drop down the 5, minus 5. And then I need to now multiply it by, or add on a 10. So then that'll be 10x, and then I have a minus 60. And then you subtract this, and the remainder doesn't matter, right? So I'm just going to leave it the way that it is. And so your final answer for your oblique asymptote is your quotient. So this right here is going to be your oblique asymptote. Except you're going to write it as an equation. So it is y equals x plus 10. Okay, so that represents your oblique asymptote. So I'm going to write that in. Y is equal to x plus 10. All right, the domain is all reals such that x does not equal, and so the vertical asymptote occurs at 6, so that the domain cannot be 6. The x-intercept is where y is equal to 0, so I'm just looking up here at the numerator, and so that will occur at negative 5 and 1. And then for the y-intercept, I'm just going to cover up my original x's so that I get 5/6. Okay, my grid actually is not big enough to graph this. So I'm just going to do it at the bottom. Oh, I need to actually do the vertical asymptote. So here's my x and here's my y. So I'm considering my vertical asymptote. So I'm going 6 and then choosing a number to the left of it, and then 6 and then a number to the right of it. So when I put in a number to the left of 6, like 5, I have positive, positive, negative. So that'll be a negative infinity. And then 6 to the positive side of it, like 7, will give me positive, positive, positive. So then it's positive infinity. Okay, I'm going to draw a much larger grid at the very bottom, right? So if you could do that with me. All right, so I need to draw it so that it is, y-intercept is 10, so I'm going to make it a lot more in the first and second quadrants. All right, so I have, I'll just draw, put in 10 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I'm going to go up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's first of all put in our vertical asymptote, which is at 6. So 1, 2, 3, 4, 5, 6. So there's a vertical asymptote here. And then I also have a slant asymptote of this. So I need to draw in my y is equal to x plus 10. So I have a 10 right here, and then my slope is going to be 1, and I drew it so that this is 10 here. So I need to now connect it from here to here. Okay, so my other information, I have x-intercepts at -5, 1, 2, 3, 4, 5, and also at a 1, and a y-intercept at 5/6. So that'll be somewhat right here. Okay, so to the left of 6, I know it's going to negative infinity, so my graph on this portion will look like this. And then for the other part, I know that there's no other intercepts, so it's got to be, I may need to just extend this a little bit. So up towards this way, and the other portion has to be right up here. Now, I want to caution you that when you're working on this or checking this on the calculator, initially it may seem like you can't see this upper portion. Okay, so I want to just show something to you on the calculator here. So let me just clear it up first. And I'm going to go into the y equals and graph this out. So I have x squared plus 4x minus 5, and then divided by x minus 6. Okay, so without doing any adjustment in my window, I just have it as a standard -10 to 10. You get this graph. Okay, so if you compare it to what we have, you could see that you actually have this bottom portion here, but you don't get this top portion. So it may appear to not be there. But remember, you're way up at 10, so I'm going to increase my window. And you need to actually go make your x at least out to 20, and then the y has to go at least out to 40. Right? So then if you do that, then the graph shows up, and you can see a little piece of it. Right? So right here is going to be your slant asymptote. Here is your vertical asymptote of x is equal to 6.